The relationship between generations often shapes the trajectory of careers, with parents serving as role models, mentors, and sources of inspiration for their sons and daughters. Whether through direct guidance, inherited talent, or the values instilled during upbringing, the influence of one generation on the next can lead to extraordinary achievements. Across sports, entertainment, and politics, certain parent child duos have exemplified how legacies are built and carried forward. Whether the Griffeys and Earnhardts in sports, the Douglases and Sheens in entertainment, or the Bushes and Adamses in politics, the bonds forged between generations can create lasting impact for the world. But that dynamic is not exclusive to blood. Often shared interests in fields like robotics can forge relationships that last a lifetime. First, for inspiration and recognition of science and technology, is a global nonprofit organization founded in 1989 by inventor Dean Kamen to inspire young people to pursue careers in science, technology, engineering, and mathematics, often referred to as STEM. Kamen envisioned a program that would make STEM as exciting as sports, fostering innovation, teamwork, and leadership. The inaugural FIRST Robotics competition was first held in 1992 with 28 teams challenging high school students to design, build, and program robots for competition. Over the years, FIRST expanded its programs to include groups of all ages. Today, FIRST serves hundreds of thousands of students annually across more than 100 countries, offering hands-on robotics challenges that emphasize creativity, problem solving, and collaboration. Through partnerships with corporations, schools, and governments, FIRST has become a global movement, inspiring students to pursue STEM careers and shifting cultural perceptions to celebrate science and technology alongside sports and entertainment. Here in Arizona, we have AZ First, which is a chapter founded by Microchip CEO Steve Sanghi. Steve's journey of extending Kamen's vision started in 2002 as a regional organization supporting and promoting FIRST robotics programs in Arizona. It serves as a hub for organizing events, securing resources, and encouraging collaboration among teams across the state. AZ First hosts annual competitions, including the Arizona Regional for the FIRST Robotics competition, and works to expand access to STEM education through outreach and mentorship. One key part of Microchip's involvement in AZ First is the participation of its employees as mentors and advisors. In some cases, multiple generations of mentorship, like the story you're about to hear today. As we reflect on the profound impact of generational influence, whether through family legacies or initiatives like FIRST, it becomes clear that the future is shaped by the connections we make today. They remind us that success is not just about individual achievement, it's about creating opportunities for those who come after. Looking ahead, the call to action is simple yet powerful. Find a way to engage with the next generation. Mentor, inspire, and invest in their potential, whether through STEM programs, community outreach, or simply leading by example. By empowering young minds to dream big and equipping them with the tools to succeed, we ensure that innovation, leadership, and progress continue to thrive. The future is bright, and it belongs to those who dare to build it. How can microchip technology promote and strengthen these generational legacies? Let's go beyond the microchip and hear a story of empowering innovation to enhance the human experience. Our guests today are Vincent Sheard and Liam Sheard. They are the first father-son duo on Beyond the Microchip. Vincent Sheard is Associate Director of our Development Systems, specializing in global integrated software. Liam Sheard is a Senior Product Marketing Specialist, specializing in content creation and our academic programs. They join us today from our headquarters in Chandler, Arizona. Welcome, guys. Thank you for joining us on Beyond the Microchip.
Thanks, Dana.
Thank you for the invite. Yeah.
In the intro, we briefly talked about FIRST Robotics and the impact of mentorship on future generations, but you're here to tell us a more personal story about how you both came together or how you both found yourself in engineering here at Microchip. We've got our tea, which you may want to talk about, but where can we start? How did you get involved?
So I joined Microchip in 2000. Steve used to promote the FIRST Robotics at the communication meetings, and my kids at the time were a little younger, so we used to buy them robotic kits at Christmas. And I remember one time I went up to help because I enjoy making models and creating, and my daughter told me to stay away and don't be involved. And Liam sort of followed in the similar footsteps. And so at Microchip, because of Steve's influence, we went and watched a couple of the programs. They were a little younger. I think my daughter was of age that we could have started, but my son wasn't. Liam wasn't. So we went and watched a couple of competitions, and it was exciting watching the activity of an actual game and a performance. And Steve was there. People from Microchip were there that you knew. Different schools. It was mostly school hosted, all the teams. And just watching and cheering and people in the stands, and the activity was just unbelievable. Really was. Really exciting.
I mean, it did feel similar to a sporting event.
Yeah.
It's like when you go to your school's football game, much smaller scale, sure. But that same energy was in the room, and that was exciting for us as kids who had done this at home, getting to see people battle it out to see whose robot can chase the line fastest, or even something as simple as that, right? But
yeah, and it's designed with intent. There's bleachers on either side.
Exactly.
It's on the floor of the basketball arena. You're
Yep.
there as if it were a basketball game. You've got a loudspeaker, you've got commentators, and then you've got two teams battling it out on basically an arena, right?
exactly.
Well, there's two teams set up of three. So
Right.
you get three teams on each side that form an alliance that compete against each other. So you end up having three First Robotic teams joining an alliance that will compete with the others.
Red
And
or blue.
They're on either side. They're color
Correct.
coded, right?
Yep.
They're on
Yep.
either side of the arena, and each team is responsible for a different control of the robot.
No, there's three robots. So you have your own robot.
Okay.
And essentially, the games normally start in January, and they give you a direction. And I've always found that whenever you want to create anything, if you don't have a concept or an idea in mind, it's difficult to put that in action. So when you get given something to say, well, these are the goals, it's much easier to focus in on it. But we went to a few of those, and within a year, they were like, we need to join the team. And I said, well, Liam's not old enough yet. She says, my daughter was like, well, okay, maybe we can wait. And as soon as he was old enough, we found a community team through Microchip. I remember speaking to Carol Popovich, who was here, very involved in the first robotics. And she gave me the name of the community team that we had, which originated from Steve and Dave Poloian, who were, I think their daughters were together in a school, and the school decided to not do it. So Steve found a place in the factory, in one of our factories, so that we could host there. And it became a community team because my children went to a art school, so they didn't really have a robotics team. So we ended up going to the community team and joining that. And from there on, it was exciting. I mean, we had really good mentors there, because I think as you go into something, you're never sure what to anticipate, what's expected, what can I do, where can I help as a mentor. And they had some really good mentors on the team at the time. And so you learn the same as what the students do. So you learn how to mentor and what there is and the safeties and things like this. And it just grew, and I loved it. I mean, the kids were just awesome,
How many kids do a team usually?
I think it really varies depending on the school.
Yeah.
Because there are schools who have, and it feels like dozens. And then there are schools who maybe have 10. And part of it is however many people are interested, however many people go to the school overall, right? The community team at one point was probably 20-ish.
Yeah, it averaged around 20. Sometimes we'd have more. It is difficult when you have a lot of students to break them up to do the different areas that you want to work on. But it's all, what I liked about it is it's all voluntary. No one was mandatory to go. It was all someone they wanted to be there. They wanted to learn. They wanted to participate. And there's all different areas. You got fundraising. You've got the Chairman's Award.
Yep.
So you're presenting material. You're presenting ideas, how you collaborated, how you came up with the idea, how you built the robot. You got to get funding because the cost of it is $6,000 per year just for the basic kit and entry. And then you can go off and buy different motors and different articulations to fabricate.
All right, so let's break down a typical project. There's a standard kit that everybody gets with
Correct.
similar parts or the same parts.
Yeah, it's the kit of parts that you buy along with your entry ticket to the competition, essentially. And so there is a standard. You get 4 motors and wheels and chains and enough to build the frame, enough to build, I think, the bumpers that you need for your robot, and then a little bit left over. So you have enough to get something driving, something working, the control board and the electrical systems for some of that. But if you're wanting to build a fully articulated 3-section arm, you may have to go buy some more materials or maybe some servos or motors. And there's a certain list of parts that you can either order from or buy from suppliers in the market.
Right.
And so it's essentially, you get into the competition with the bare bones kit. And part of this fundraising is to make sure that you reach that goal. And then also to build your budget for the project you're about to do. Because you don't know at that time still what the goal is, what the game is, how you want to design a robot to fit that specific criteria. And you're kind of just trying to build as much buffer. So if you want to build in computer vision to your robot, you can afford to do that, right? Things like that are part of the fundraising aspect and planning and the preseason. So anything that happens, I think, in the first half of the school year is usually geared to that, getting initial soft skills, maybe working on last year's robot to get people used to working before they actually start on this year's robot. Little things like that. But
And outreach, you have events that you'll go out to communities and demonstrate what you do to try and spread the word, bring more people in, whether it's mentors, whether it's students, either one.
Yeah, especially as the community team, which I found interesting. And to touch on this, yes, the people who join the team are all eager to be there. That goes doubly so when the team isn't even available at your school.
Oh,
You want to do this so bad that you went searching outside to try and find some place where you could do this. And if you end up at our community team, you're very impassioned and inspired to work and to learn and to explore, right?
and it's the competitive nature of the game, right?
Somewhat. I mean, in the competitive scene, you do make those alliances with other teams too. So if we've worked with your school before, we're familiar with how you guys operate. We'll maybe ask you to help, especially if your robot complements ours really well. And we've seen you throughout the build season and we're part of the scrims and such. But normally for the community team, our rule was if you have a school team, you kind of have to go to the school team. We don't want you jumping ship just because you don't like the people there or anything like that. No, it's you have a team to support. You should go and support them, right? And encouraging that and fostering that, because it's well, even if you're not on our team, you might be in our team when we get to the competition.
Right. So it's a very positive nature, and I like the way that they frame everything, and I like how they position everything for all the teams. But are there rivalries? Is there a team that that you would go up against, or do you know that you might work with them someday?
Yeah.
You always have some rivalry. Everybody wants to win in their heart, right? So you go out, and there's some teams that they are really strong. They've got really good mentors who are in the industry like aerospace and stuff like that, and they just come up with brilliant ideas. And then they have machine shops that they can make the parts and things like that. So you may get a little bit of jealousy in there because you don't quite have the same capabilities. But when you get down to the game, it just drops out, and it's just you just enjoy working with the other teams. And if you happen to form an alliance with one of them, it's great because now there's no rivalry between the two because now you're on the same alliance. So you'll have rivalry when you're actually participating in the game. But when it comes down to it, in the end, in the finals, you find a routine that you're rooting for, the team that looks the best. They do the best at what they do,
And hopefully that's your team. But
So every base robot has the sled, right? It has the square with the bumpers on the side and then the motors with wheels underneath. And then from there, you can then build up depending on what? Creative ingenuity, sponsorship, budget, resources of the school. What adds to the ability to build a specific kind of robot? You said before if there was engineering expertise from a mentor.
sure.
Yep. I think it is what we used to do when we started is we would have some brainstorming from the students. The mentors wouldn't get involved. We would have the students come up with ideas of how they wanted to play the game, how they want to achieve the goals. Maybe we'll get to it later, but we had one that was throwing frisbees, and that was probably one of my favorite. But the students came up with ideas, and then we as mentors would gather it and say, okay, which are the ideas that we can try and utilize that the students have brought forward? So not our ideas, but their ideas. And then how can we make them? So you've really just got to come up and try and be creative, because all the objectives, you don't know, like Liam said, you don't know until you actually get involved in the start of the game. So we used to go off and just buy a lot of secondhand aluminum from one of the companies in Phoenix. And angle iron is not angle iron, but angle aluminum. We were lightweight. We'd buy a lot of just different pieces and then use what we needed. There was sort of a standard that whenever you bolted anything together, it was 1/4 bolts, and they always had lock nuts on them. You never ever did anything without a lock nut, otherwise it'd come apart. There were sort of certain things that you learned from previous mentors, you know. But yeah, you would just try and come up. You had pneumatics, so you could use pistons. You had pneumatics. You had motors. You could use whatever you want, really, as long as it didn't go over or out of the bounds. John, when you started the game, you always had inspections on your robots. You had to pass certain criteria, and if you didn't, then you weren't even allowed to go on the field. So it wasn't allowed to weigh any more than a certain amount. It had to have electrical checks so that there wasn't any shorts or anything going to occur. Dangerous, sharp edges. You know, they used to do a really good inspection, and that was all voluntary.
And I think one of the other ones was making sure it fits within the base of the robot. So even if it has an arm, it has to fold up at the start of the game so that it stays within that base. And some games, depending, would allow a little bit more flexibility with like how far in total could it reach versus others where it was maybe even not as advantageous and people didn't often design in that way. So it was kind of reinforced with those rules. But exactly what he's talking about is these criteria that are just generic, always going to be requisite at the beginning of the competition. Before you even get to the actual design elements or interesting pieces that the students come up with, because believe it or not, students who aren't restricted by the bounds of what motors can do or how magnets work or all these other things come up with really ingenious ideas, right? Getting to see that prototyping from even myself and my peers when I was a student and seeing what they come up with even when I turned into a mentor was actually quite ingenious, right? And innovative and curious. They're not restricted by the same way that we are maybe as mentors from years past or with experiences like maybe we make a robot like we did 2 years ago because this game is similar. No, none of that. They honestly came to the table every time with something new, interesting, and innovative. And we had at the community team maybe 6 or 7 groups of small pairs or trios of students who would generate these interesting ideas and then have to present it. And yeah, some of them are wildly outlandish, but that's half the fun of it, right? And some of them are like, well, we didn't know at all about how to deal with the last half of the game because that's a thing that we didn't think about. But all we talked about was how we were going to tackle kicking this ball to make it into the goals every single time and the consistency of it and the mechanisms of it. And then as a mentor, your goal is to help them figure out how to build that, right?
So let's get into that. One of the competitions that I saw, the task was to pick up a cone and stack it on top of a pole. And then another one was to actually grab a ball and put the ball inside of a basket. And those were the tasks. Do you have any favorite from your memory that were just really unique tasks that the kids had to figure out a way to do?
I don't remember the cone and the basket, but
I think that was before our time.
The robotics that I really enjoyed was the throwing of the frisbees. You used to collect them on the side, and you would try and shoot them out into a slot that was about 6 foot wide, maybe a foot high opening, and you wanted to see how many you could get through. And so you would
get points for accuracy, right?
Correct. So you'd have a trajectory that was set. Some people would have them where you could adjust them. So essentially, you got to park the robot where you can be, and you would fire these off, and you would get like 3 or 4 or 5 in right through. Once you got one, they would just follow like a weapon, just firing these frisbees going through the hole.
It's almost like a pitching machine.
It was just cool.
On target
just
every
to
time.
watch, and just see it happen. It's just exciting,
I remember you talking about the prototyping for that particular season. I think it was 2014, because I remember the guy who wanted to do that design, what we ended up with.
Yeah, he came by and he said, I think we should put a wheel in a semicircle and shoot them over. And I said, okay, well, take your idea, go to build a prototype. And we had a half field in our warehouse.
Yeah.
And see if you can do it, And he went out and he had a piece of wood and he made a platform out of plywood and put a bit of a circle on it. And he drove a wheel. And I mean, it would go maybe a couple of feet to start with, and we would work on it. And I said, okay, if you can get it within 10 feet, just shoot 10 feet. That's what we'll go with. And the next week it was there. So then it was a matter of, okay, we've got a good prototype. We've got a good idea. How do we refine it? And then you build on that. How can we cascade more frisbees in a line so that we can fire more as we're going along instead of one at a time, And it developed from that. We had a little bit of a entry platform that would be on a hinge that would lower down so that we could be in the size constraints that we had to be in.
Mm-hmm.
And then it would pick up and go onto the side and people would load it in. So you could load probably 4 at a time and he would spin up the wheel and then you get where you want to be and he would just fire them off. And I think he actually drove it that year as well. So he knew how, what the robot was going to do, where he had to be and everything, and it was just exciting, it really was.
So to continue to paint the scene for the listeners, this is a live competition. Like all the robots are moving at once. They're not taking turns.
Right.
So are there scenarios like in professional sport where you have a specialist and then you have like a bruiser or an enforcer whose job is to stop the other player from doing it? Is that allowed in competition?
Absolutely. I think some of the interesting alliances form where you have 1 or 2 that are really good at scoring the points. And the third one is maybe not as good at scoring the points, but all 3 of them know that. They come and they talk together before the game and they say, look, our robot literally hits 5 frisbees into that hole every single time and we'll do it every 30 seconds because that's the time. Your goal, your job is to make sure no other robot gets in our way from picking more of them up. So if you want to go to the other side of the field and play defense for us,
right,
we'd love that. You happen to have a couple of really good
so one
arms.
robot's job could be just to ram the other robot to
Or get in their way. I don't think we really used to battle robots
Right.
as you see on the move where you go
just
and try and
interference then.
exactly.
But
yeah,
like
Yeah.
we're saying, we had a fixed angle and we needed to be in a very specific place on the field. If some other robot comes and parks right where we're supposed to be and just doesn't move, we're kind of SOL,
Yeah.
right? Like there's not much we can do if we can't move that robot. We can try, but that has happened before. And depending on the game, I know they had ones that were basically like teeter-totters over a massive speed bump. So most robots couldn't clear the speed bump. It was like a rectangle. It wasn't a round. So if your robot wasn't tall enough, you're just going to not cross that boundary. And so people would park their robot on the other side of the teeter-totter so that I wouldn't go down. So that you can't go to the other side of the field and pick up more items
Right.
or more pieces for the game. And that was incredibly effective at stalling certain teams out from being able to score those points. A lot of that does come down to when you're in the alliance and you're actually strategizing for the game
Right.
and playing it. The drive teams and the people who work on the robots, you have to pitch your robot to your teammates at what it's good at. And then build a strategy on how to play the game just like you would in a team sport, right? And even then, you may have planned to fulfill a role and find yourself in a situation where that's not needed, or we have a different goal now. Maybe it's, hey, we all 3 of us need to balance on that teeter-totter. We have one robot who can do it. Your goal is to get your robot to park right next to it so it can pick it up.
Right. So
That's all we need you to do.
Not violent per se, but there is office and
Yeah.
defense.
Oh yeah, I remember
Absolutely.
one time a robot was pushing the other one, and he was trying to get away, and the one that had more friction on the floor, and he could literally hold it, push it backwards, and push it in the corner, and you just kept it there, you know, so you prevent them from going to scoring. So it's an alliance. You build how is the best way to win the game as a group.
And funny enough, there's also refs. So the game does have rules.
Yeah.
There was a basketball version one. It was like, hey, if they're standing in the key, you can't touch them. You can't even bump them. You can't even look at them, right? Like, just leave them alone. And sure enough, yeah, if you get in the way of that, even if it's an accident, there's a ref watching and it's going to give you a little penalty if you do so.
Yeah.
Exactly. If you pin a robot for more than 3 seconds, that might not be allowed. And so you're like, well, I can hold him there for a little bit, but then I'm going to have to back the robot up.
Flag or a whistle, just
Exactly.
like in
Yeah.
professional sport.
So it does really much embody that same professional atmosphere of like team sports.
Thank you for listening to Beyond the Microchip, brought to you by Microchip Technology. This concludes part 1 of our 2-part episode on FIRST robotics and generational influences in engineering. Join us next time as we pick up our conversation where we left off and explore what happens outside the arena, where FIRST robotics brings additional opportunities to benefit young minds. Thanks for listening. All right, we've got our tea. Tell me again what you guys are having?
This is Barry's Irish breakfast tea.
Irish breakfast. Okay.
Yeah. But it's Irish breakfast tea from Ireland.
Not to be confused with...
It's not English version of Irish breakfast tea, because that's very different, right?